In this module, we are going to look at relations as sets and then look at some properties associated with these relations. So if I have a relation, I can define its property. The first property we are going to look at is reflexive. So a relation R is said to be reflexive if the pair AA is in relation R for every element in A. In other words, we want for any A, if A is in the set A, the little a is in the set capital A, then this pair AA must be in the relation. If this property is satisfied, we call the relation reflexive. If the property is not satisfied, we say that the relation is not reflexive. It's as simple as that. We are going to define quite a few different properties of relations, but essentially what we are going to do is we are going to say what kind of pairs we want in the relations and what kind of pairs we don't want in the relation. The second property that we are going to look at is irreflexive. A relation is irreflexive if the pair AA is never in the relation R for any element A. That means for all A is in A, then the pair AA is not in R. I want you to pause the video here for a second and I want you to think of the following problem or following question. Is it possible that a relation is both reflexive and irreflexive? Is it possible? And is it possible for a relation to be neither reflexive nor irreflexive? I want you to think about this. Pause the video for a second. Now, the answer is that it is possible that the relation is neither reflexive nor irreflexive. That means it's not reflexive and it's not irreflexive. In other words, these two are not the opposites of each other. The reason for that is this is saying every pair has to be in the relation. This is saying no pair can be in the relation. So there is something in the middle, which is some pairs could be in the relation, some not, and that will give you a relation that is neither reflexive nor irreflexive. So this is the point that I just made. A relation can be both not reflexive and not irreflexive. Let's look at some examples. So here the set is 1, 2, 3, 4. We want to know whether the relation is reflexive, irreflexive, or neither. So here we have R1. So in order for it to be reflexive, we want the pair 1, 1, 2, 2, 3, 3, 4, 4. They're all there. Wonderful. It's a reflexive relation. I will go through this quickly, but feel free to pause it to verify that the answer matches with what you expect. So this one is not reflexive. It is in fact irreflexive because here none of the pairs 1, 1, 2, 2, 3, 3, 4, 4 are in the relation. Let's look at this. Again, this is irreflexive because none of the pairs 1, 1, 2, 2, 3, 3, 4, 4 are in this relation. R4 this is reflexive. It has all the pairs. It doesn't have anything else, but that's okay. We don't care about that. This one is irreflexive because I don't have the pairs 1, 1, 2, 2, 3, 3, 4, 4. None of them are there. I'm good. This is neither And this is because the pair 2 2 is there, that means it's not irreflexive, and I don't see the pair 1 1, and that means it's not reflexive. Here is the second property. It's called symmetric, and basically what it says is if the pair AB is in the relation, then the pair BA must be in the relation and vice versa. So it's basically saying if I take any A and from the set A, another any B from set B, if A is related to B, then B is related to A. If this property is satisfied, we say that the relation is symmetric. If the property is not satisfied, we say that the relation is not symmetric. There is another definition called antisymmetric, and it is not the opposite of symmetric, but here what we have is a relation A is called antisymmetric if whenever AB is in the relation and BA is in the relation, then A is equal to B. In other words, it's okay to have pairs of the form 1 1 because the reverse of it is exactly the same. However, it is not okay to have pairs of this form. This is not okay. What this is the first pair 1 1 is okay. The pair 1 2 and 2 1 is not okay because in that case I have A and B that are different, and the pair AB and BA is in the set. The easiest way to think about antisymmetric is the relation less than or equal to, because if A is less than or equal to B and B is less than or equal to A, that means A is equal to B, and that's exactly what we're doing in this situation. Once again, a relation does not have to be symmetric or antisymmetric. It can be in fact both, and we'll see instances of this, and it is possible that it's neither. So the way we can write antisymmetric relations is if I have ARB and I have BRA, then A must be equal to B. Again, as I said, the definitions are not complements of each other. It's possible for a relation to be neither antisymmetric nor symmetric. Let's look at the previous example and see which relations are symmetric, antisymmetric, both, or neither. So let's look at the first relation. Now it's going to take a little bit of time to figure out whether the relation is symmetric or not, because it's a little bit more complicated than the reflexive or irreflexive. So here I have the pair 1 1 1. The reverse is the same, so I don't have to worry about these kinds of pairs. I have 1 2, the reverse would be 2 1. Wonderful, I have that. I don't have to worry about 2 2. I don't have to worry about 3 3. I don't have to worry about 4 4. And that means this relation is symmetric. Let's see if it's antisymmetric. And the answer is it's not, because I have this pair 1 2 and 2 1 that is there. That is going to prevent it from being antisymmetric. Let's look at this one. I'm going to pause here for I'm going to ask you to pause here for a little bit to answer this yourself. Okay, so I have 2 4 and 4 2. So the reverse of 2 4 is 4 2, the reverse of 4 2 is 2 4. I'm happy with respect to symmetric property, but I'm not happy with respect to antisymmetric property, because here I have two elements, A is 2, B is 4, and AB and BA both are in the set. Let's look at this one. This one is not symmetric. The reason it's not symmetric is because I have 1, 2, but I don't have 2, 1. And as soon as I find one pair, I don't have to check for the rest. It is, however, antisymmetric. And the reason it's antisymmetric is because I don't have any pairs of the form AB and BA simultaneously here. I want you to think about why this is true. Make sure you understand that. And the reason, again, I'm going to repeat, the reason it's true is because I don't have any pair of the form AB and BA simultaneously in this relation. Let's look at the relation 1, 1, 2, 2, 3, 3, 4, 4. This is symmetric and antisymmetric. Let's look at this one. So to see for symmetry, I have 1, 3 that requires me to have 3, 1. I have 1, 4 that requires me to have 4, 1. I don't see it, that means it's not symmetric. It's not antisymmetric either because I have these two pairs that are going to cause the trouble. That's going to make it not antisymmetric. If I look at the divides relation over positive integer, then it is antisymmetric because a number divides itself. But if in other words, if A divides B and B divides A, then A must be equal to B. That will make it antisymmetric. But it's not symmetric because 2 divides 4, but 4 doesn't divide 2. Let's look at this relation. So here 2, 2 is not going to cause a problem. 2, 3 requires me to have 3, 2, which it has. 2, 4 requires me to have 4, 2. I don't have that, and therefore it's not symmetric. It's also not antisymmetric. I want you to be able to understand why each of the relation is the way it is, and if you are given a relation, to figure out whether it is reflexive, symmetric, antisymmetric, etc. The next property is transitive. Transitive says if the element AB is in the relation and the element BC is in the relation, then AC must be in the relation. For any ABC, if A are B and B are C, then this must imply A are C. Let's look at this. Okay, so checking for transitivity is more complicated because now I have to look at two pairs and see if I can combine them. So first observation that I'm going to make is pairs like 2, 2 are not going to make any difference, because in order to combine the pair like 2, 2, I must have something that starts with 2 something. So let's say it's 2 comma x. When I combine them, the pair that I'm going to get is going to be 2 comma x. In other words, if I combine 2, 2 with something, then it's going to give me one of the pairs that I already had, so it's not going to cause me any trouble with respect to transitivity. The same thing it's going to happen if the pair I could combine from the other side, and that is also going to give me the pair that I had before, and that means it's not going to change. So pairs like 2, 2 I don't have to worry about. Now for pair like 2, 3, I can combine it with something that starts with 3 comma something. So I have to worry about the pair 3, 2. I have to worry about the pair 2, 4. I don't have to worry about the pair 3, 3 because it is the same kind of thing that I had with the pair 2, 2. Okay, so if I combine these two pairs, I need to have the pair 2, 2 in the relation. If I combine these two, I need 2, 4 to be in the relation. Both ones I'm happy with because I see 2, 2 over here, and I see 4, 4 over here. That means I'm happy with this. Now let's go to the next one. I have 2, 4. So in order to combine this, I need a pair of the form 4 comma something. I don't have such a pair, so there's nothing. This pair can cause me trouble. This one I need to worry about something that starts with 2 something. I have these two pairs, but as I said, I don't worry about 2, 2. So the only pair I have to worry about is 2, 3. And when I combine it, I'll get the pair 3, 3, which is already in the relation. And then for 3, 4, I don't have anything starting with 4, so I'm good with this. That means this is transitive. This is going to require a little bit more thinking on your side for each of the examples. So please pause the video as appropriate to see if you agree with the property that is there. This relation is also transitive. This relation is not transitive. The reason it's not transitive is because I can combine these two pairs to get the pair 2, 2 or 4, 4. Neither of those are in the relation. So let's see what we can do here. I can combine 1, 2 and 2, 3. That will give me the pair 1, 3. It's not in the relation. That means this is not transitive. This relation is in fact transitive because you cannot combine any two pairs, and if you don't combine any two pairs, then because of the way the implication works, we don't have to worry about what other pairs are in the relation or not. This one is not transitive. I want you to think about why this is not transitive. Try to find as many instances of this as you can. The divides relation, this is transitive because if A divides B, B divides C, then A divides C. So here is the summary of what we did so far. I want you to make sure you understand each of these as to why this is true, that is, the relation has the given property or it doesn't have the given property. Once again, we have reached the check before you go ahead slide. I want to make sure you have understood the previous slide and specifically why the given relations have or do not have the property of reflexive, symmetric, antisymmetric, etc.